Hello everyone. Today we are going to dive into elif statements in Python. Now the default else if code in Python just helps us to execute binary conditions. However, in real life examples and in real life engineering applications, as we will see, we need more than just pure binary because many events are mutually exclusive. That's why we use elif, because other than the normal else if, as soon as one of the condition in the code block is evaluated as true, it stops there, and thus helps us in many real life cases, as we will see. So now we will start with the syntax, and I'll be sharing the screen. So the syntax is straightforward. We start with an if, follow with as many elif statements as we need, and then we optionally end with an else. So the thing is, as soon as the Python interpreter finds a true condition, it skips the rest of the chain. This is much more independent, much more efficient than using independent statements. So we will start with an example of a live code. So here you can look at this standard grading system. We have a score and we need to categorize it, like what is the grade. So as you can see, if the score is greater than or equal to 90, then it will print grade A. If it is greater than equal to 80, it will print B, and so on. So the clear idea here is that this elif code will make sure, so suppose somebody has the score of 85 as we have above hard coded. So what will happen is, as soon as the elif score greater than 80 block is triggered, all the next code of it will not get triggered, right? So using normal, if we have used only normal if statements, it would trigger B, C and F as well, right? The next code blocks as well. Here it triggers only the required B block. Okay. Now for an engineering application, we can think of a smart HVAC system, which is the heating, ventilation, air conditioning system. So here let's say we have, this is a real life example. So let's say we are having a sensor and it decides whether to heat things, cool things or stay idle. Okay, suppose a combination of heater and AC is there in a room or any lab like experiment, right? So we are having the temperature equal to 24. This is the data we get from sensor. Okay, and now just by the if elif conditions, we can decide the value of the mode, which is whether we want to do heating on if the temperature is very less. If it is between 10 to 24, say, we will say eco mode, fans only. If it is greater than 24, we will say cooling on, or else like anything else, because other temperature values cannot actually come. So that's the sensor doing something wrong. So we will say system error. Okay, so this is the simple idea of the code. So thus we can understand a few things. First of all, by using elif, we can create the code which is clean, readable and computationally efficient logic, right? And the second part that is to be understood is that in real life conditions, as with the HVAC system, or let's say IoT design systems, we definitely have the if else conditions. Like from what I have also studied is the basis of machine learning algorithms is also somehow a parallel of if else. Like if the semantic understanding, or if the vector databases have a value than this, then do this action. So many if else condition at a very small level are all working together to kind of create a next word prediction, which is a very basic level of transformer architecture that nowadays large language models use. So this is a very short example of Elif statement, and thus by understanding it in our students use cases, we can design a very systems efficiently. And in general as well, the although exact structure is very much updated, the idea and the logic follows in many real life cases that we see around us and even in the advanced technologies. Thank you.